Hey, welcome to the AdaShape 0.1.5 alpha release video. In this version we've added SVG import. You can now bring in SVG drawings and use them directly as profiles for extrusions. We don't have full 2D sketching system built in yet, so today I'll just show you the import workflow and what you can do with it. So we have prepared some SVG files to get started with. And the workflow is very simple. You just grab one of these shapes and you drag them in here. Now, after they've been dragged into AdaShape, you can use this top widget to set the extrusion distance. We have two types of extrusions. This is what we call solid, and then we have a buffered shape, which basically takes in the lines and converts them to walls. And in this mode, we have this triangular widget down here, and we can pick it, and we can use that to set the wall width. And there's actually no limit. You can even close those walls and convert this to a kind of a closed solid shape itself. Now, these are compatible with the existing shapes, so we can take, let's say, a sphere, and we can do a Boolean cut with it. So these are completely compatible with the previous modeling primitives. Now let's go a step back. But the extrusion isn't the only thing you can do. You can also have these, what we call edge treatments. I click this edge treatment over here, and now you can see there is this gray rectangle over here, and when we drag that gray rectangle, you can see these edge treatments are modified by it. We have the end edge treatment, and then we have a start edge treatment, and those can be configured separately. So you can get quite fast something that looks like this. You can also take in the edge treatment and configure it so it's this round shape. So you have an option of making these round shapes and these sharper shapes at the edges. Drawing these shapes is really easy. Let me show you a quick way of how to start sketching them. I'm using this online tool called Method Draw, which I have no affiliation with, but it's just nice and simple. So we can, for instance, take this pen tool and start drawing some random profile thingy. Yeah, that's nice. And then we can just save it, and then we can drag and drop that over here. So, and now we have this also as a profile here. Other cool thing we can do here is just we can have pure lines. So we can take that line and we can export that one. So you can, this is the line shape we made. Let's remove this guy so this is more obvious to you. So this is the line we made there. The only presentation this has is this buffering, but you can already see that we can kind of, the modeling from the part of the profile generation is actually quite straightforward for you. Let's do something here. So for instance, if you want to model a nice house, you could start here by just doing a rectangular cross section here, then we can drag it here. Let's remove that guy. So we have this rectangle here, and then we can do a copy. So let's say that's the base of our house, and now we have a copy of this, and we can add this bevel end edge treatment, and then we can use it to create this roof-like shape. It maybe has a slightly too much of that edge going over it, but now it's kind of looks more like a roof. And then we can use this scaling tool here, this white rectangle, to scale it a bit larger. And now we can notice actually we have some more room to go for the right. Okay, so it's larger now, so we need more height for those treatments to have the space to actually create that nice peaked shape. All right, and now we have these two guys on top of each other. We can then select both. Use this align tool. We can drag this down here, and then we can merge these. And this is sort of a house. Okay, let's do a quick desk organizer. I guess this doesn't have. Do we have some nice shape for a desk organizer? Yeah, that's nice. Let's start with that. Okay, so this is our basic shape for desk organizer. We're gonna export it here, and then we'll just use it as the base shape. So first we can copy this base plate away. Although that's a bit small, let's do this again. So these are centimeters over here. Let's have just one scale. So we set the end edge there, and then let's say 1, 2, 3, 4, 5, 6, 7, 8. You will notice we don't have dimensions yet. Alpha version. Okay, so we have this base that's like 8 centimeters wide, and this will be our base plate. So we can just copy it. We can convert it to this buffered presentation and extrude it. And now we come to the part where this is actually a modeler, which is intended to be used for designing things. So when you're doing a desk organizer like this, we want to be pretty specific about the width of the wall, and we can set it here. These are centimeters, and a typical wall width for this type of shape might be like 2 millimeters. So we're going to set the buffer distance to 0.1, which is kind of half of it. And now we have these walls here. They are a bit rough maybe from the top, so let's see if we can add some edge treatment over there to make it slightly smoother. And now it's too sharp, I don't like it. So let's just make it. All right, there we go. It's nice and smooth. And you notice that we have this base plate over here. So let's put them that they are aligned like that, and they're one single shape. So now we can bind them into single shape using the union. And usually desk organizers like this have these holes as details. So let's add a nice hole here. I'm gonna, oh, sorry. Let's add, so now what I'm doing, I'm putting the rotation snap on, so we can have this nicely planned rotations. And let's put the scale to 0.6. That sounds good. Then we can just drag this guy over here. I'm gonna do something silly here. To show you how we don't have any regrets. So we made a hole there, but it's sort of not that nice. We can actually edit it online. So let's do a clone of this thing, and then we're going to explode it. And you will notice that this is actually then a light clone of this other part. So now we can just grab this one, the whole part, and as we move it, you notice that the hole on the target is modified at the same time. And that is actually now, it's looking pretty good. I mean, I'm no designer, but let's go with it. And in matter of fact, maybe we want to make it symmetric. So we can just take this part over here, take this distance widget, and then extrude it all the way to the other side. So now we have this nice symmetric hole. Maybe we will make this slightly smaller. I don't like the way it goes over those borders. Yeah, that's nicer. So let's just put it over here. So it's right. Okay, that's better. And after we've done this, we can delete these. This is alpha version, so this is not the final UX. We will come up with better UX, but you will see that the underlying engine supports doing stuff like this. All right, thanks. So so now you know how to use SVG profiles in AdaShape, and here's what makes that actually interesting for you. SVG is the standard format for vector graphics, and unlike photo, which is a grid of pixels, a vector image is defined by arcs and lines. The same mathematical primitives used in manufacturing since the 1960s. So if you've ever drawn a shape in Google Docs, Figma, or Illustrator, you already know how to create a geometry that's inherently manufacturable, right? And that's interesting from the point of view that this doesn't need to be actually that hard if you want to manufacture and design shapes on your own. And even though it might seem far too simple compared to professional CAD, there's no trick here. The math works out. These are real manufacturable shapes. And this is the first major feature that starts to show AdaShape's modeling philosophy in practice. Thanks for watching, and if you have any thoughts, please share them in the comments.